Consider the following relation schema: student, roll number, name, branch, marks. The SQL query which displays all the roll numbers of students who have scored more marks than at least one student of ECE branch is. So here in this question, relation schema for the table student is given as roll number, name, branch, and marks. That means student table consists of attributes roll number, name, branch, and marks. And we have to find the SQL query which displays all the roll numbers of the students who have scored more marks than at least one of the student from ECE branch. So if you see option A, select distinct from S dot roll number from student as S and student as T, where S dot marks is greater than T dot marks and T dot branch is equal to ECE. Here we should compare in order to retrieve the tuples which we want, we have to compare the table student twice. So from student as S and student as T, here table student is compared with itself. The tables which are in the from class are compared. That means here first of all cross product of student table twice. We have to take student table twice. That means here first table is renamed as S and second table is renamed as T. Here the table is same but the name is different. Here we are finding the cross product of these two tables, and the condition is S dot marks should be greater than T dot marks. S dot marks should be greater than T dot marks and T dot branch. Here T is the second table and S is the first table, and T dot branch is equal to ECE. That means the marks from the tuples which satisfy the marks column in the first table, which are greater than the marks column in the second table, and the branch name in the second table must be equal to ECE. Those tuples are selected, and from those tuples only those tuples only those tuples are filtered, and from those tuples we are selecting only attribute rule number from the first table. That means here the students who have scored more marks than at least one of the student from ECE branch. So those tuples are filtered, and from those tuples we are selecting only rule number of that particular student. And here distinct is used. Why? Because select clause will display. That means if particular student has got more marks than 2 or 3 students, if you don't use distinct, here that particular rule number of that particular student is displayed twice. In order to avoid that, we are using distinct. So that is the concept. So if you see option B, select a distinct roll number from student where marks greater than some. Here in this part again one more query is there. Let us try to find out what this subquery retrieves. So here this subquery retrieves select marks. That means only marks column is selected from student where branch is equal to ECE. That means all the marks of the ECE branch or all the marks of the students from ECE branch are selected by this column, by this query, and this query is placed in where condition. So here select a distinct roll number from student where marks is greater than, so these marks should be greater than sum. Sum means by at least, sum means at least 1. in SQL queries, greater than at least one. Greater than at least one is replaced by greater than sum. At least one is nothing but greater than at least one is nothing but sum. So here greater than at least one is nothing but greater than sum. So we can say both options A and B retrieve our required information. So here correct option is option C, which states that both the options A and B retrieve the roll numbers of students who have scored more marks than at least one student of ECE branch. So here correct option is option C. Here in this question, two grammars A and B are given, and we have to identify the nature of those two grammars. That means we have to identify which one of them is ambiguous grammar. If we see grammar A, here grammar A is both right and left recursive. Whenever a particular grammar is both right and left recursive, then it should be ambiguous grammar. So here option A is, here grammar A is ambiguous grammar. So if we see options, the options, both the option A is both the grammars are ambiguous. So we can, that means if we see options, first option is both the grammars are ambiguous, both the grammars are not ambiguous. So here we can eliminate option B. Why? Because it states that both the grammars are not ambiguous, but we can see that grammar A is ambiguous. So we can delete, we can rule out this option B. If we see option C, only grammar A is ambiguous. Option D, only grammar B is ambiguous. We can also rule out this option D. Why? Because it states that only grammar B is ambiguous, but we got as A is also ambiguous grammar. So we can rule out this option D. If we try to derive any string from grammar B, we'd be getting unique leftmost or unique rightmost derivation. So we can say that grammar B is not ambiguous. Whenever we get more than one rightmost or leftmost derivation for one particular string, we can say that grammar is ambiguous. But for grammar B, all the strings contains either any string will contain either leftmost, any string will contain only one leftmost or rightmost derivation. So we can say option grammar B is unambiguous and grammar A is ambiguous. So here correct option is option C. So we can say if any particular grammar is both right and left recursive, we can simply put we can simply consider that grammar as ambiguous grammar. So here correct option is option C.